Yeah, I think that's good. All right, so I will jump into this thing. What I want to show you is that generally the way an Inventor works for me is once I've put parts on drawings, that to me becomes like the master file, I guess. And so a lot of times I will just open the drawings and then open my parts from drawings is really the workflow that once you have a drawing set, that's kind of how I establish my workflow. Um, so I'm just going to open my drawings here, um, which I just need to do. I've got my project loaded, yes, but I think I worked outside my project for a minute. Not that far outside. Let's see, general. But yeah, I have my drawing set. I've only just placed views and placed parts. So, but this becomes the way I generally will access all my files once I have them on drawings. And so I would open my drawing set and uh and then I can open and then I can go to whatever sheet and whatever parts I'm looking for to open up. This is what I'm working on still is this is the assembly and making parts from it, right? So I'm going to open this up from here. So I open this stuff up for my drawings a lot. And in this case here, what you'll notice is in the assembly, underneath it is that part model. Sorry, that part assembly. Yes, I should, yes, I should cast to you guys. Yes, I will. Thank you. I totally am. Yes, thank you guys for checking. I do need people to check myself. Those are helpful, actually. I forget. I just get rolling. And yeah, yesterday I forgot to record my screen the whole time. So I re-record. So the recording from yesterday was a re-recording, actually. So it's okay. Because I actually was able to put in some of the issues that we were working with after class. And so I actually put those in my video. So worked out good. There's always a silver lining. Let's see. Yeah, and then what's interesting is yeah, I can get to these individual parts. From here, you can't necessarily get to the base component from this, even though there was a base component and this was exported from it. If I want to get back to that base component for these, I can open an individual part that was created from it, and that base component shows up on the parts right here on the model list. Anyway, this is how I would drive down and get to this part again and to make my changes, which I really feel like is this upstream part from all of those, right? So anyway, that's just me and how I would normally navigate from the drawing to the parts. Sometimes I have to go to the part to get to the base component because this isn't going to show up on a drawing, but you can still drive down to it. So and this one, yeah, is what we finished. What I ended up having, like, just a recap, if you didn't watch that video and what didn't work, I unfolded it, refolded it here, or unfolded it, did a cut, and then I refolded it here at this stage. And then normally that should update and follow that downstream process where I go back to this assembly and it'll accept those updates, and then those parts will accept those updates. It didn't work for everybody. So what they ended up having to do was re-export this part or essentially almost make a new component of this part. And even name it a new name, which was fine with me. Like I had named it once and it was kind of a failed part. Um, it didn't seem like it wanted to let you overwrite that name and overwrite that part. So, and I thought that's how that works. So it kind of caught me off guard that I was thinking you could just overwrite, use that same name again, but kind of send a new part with that name. If you get errors doing that, if you just rename it to a new name, just a new part number, then that seemed to work for everybody. It was almost just like it wouldn't accept this update downstream from here. And that was unusual. But in the event that that happens, I can just kind of make a new component. What I have to do as a file manager mentality is when I have to get into those part files eventually. And I think I discussed this in my video just a little bit, but just for a quick recap, you have to you kind of have to watch yourself and when you so I would have if that would have happened on my end, I would have had that part that didn't work with a part number, and then I would have remade a new component with a new part number that's kind of the same part, but it does work. I like to remember to purge those parts that were failed out of my parts list, out of my parts files, just so they don't continue to be like bundled along the whole um what am I saying here? This one here. Yeah, so it'd just be me keeping track if I had a failed part in my parts file. I would like to, usually I'll move it to an obsolete folder rather than just delete it out. So that can happen. That would throw my number sequence out of sequence. That doesn't even matter to me. I don't even worry about that. Um, so I would just want to make sure I don't have two of the same part with kind of two different part numbers that are really confusing for me to ever know which one worked until I really drive down and find out that's the one that has the failed flat pattern or something. So it's nice to keep track of those, purge them into some folder, get rid of them. And one reason why I do that is because when I'm working in a library or vault system, I wouldn't want to send those failed parts like to lock down in a library or vault. It's just further confusion. So before I would check those in, I would like to clean up my parts files. And sometimes you got to do that as you go. Otherwise, you'll never remember that you had a failed part. So it's better to do that as you work along. And if that's the case for you, I would get rid of that part somewhere. I mean, you can delete it, but I always just move them to obsolete folders. My obsolete folders, I never check into a library or vault system. So anyway, that's a little bit of file management tutorial there for you. So when I have that issue, and that is common to have. I occasionally have parts that fail, and I've got to redo them. So moving on from this, so hallelujah. I think I'm gonna say that is pretty much ready. I need to drop that part onto a drawing sheet yet. So I still have that in my mind, and I don't have a place on the drawing for that necessarily. So I've got that one in the back of my mind, or I've written it down on my paper next to my table. And I'm ready to start some new, we need to make our quarter-inch parts for this. So that's what I'm going to do. So I'm going to open up a new part, a new sheet metal part. Yes, an English sheet metal part. Create that thing. This is going to be another part assembly. Something I'm just going to make the two end plates and then send them to that target assembly. So what I'm going to do is set my sheet metal defaults to kind of match what we've been doing. I need to make a new one here for this part. New sheet metal part. It is going to be quarter-inch, and I'll just use the fractional uh, quarter-inch SS plate is what I'm going to call it. Stainless steel plate. And then I'm going to make that stainless steel is what we've been doing. And I'm going to make it the thickness that quarter-inch is, which is 0.25. The only other thing we changed, so I'll go over to the bend tab here. And instead of being a whole thickness that I'm going to relief cut, I've been doing this 30 thousandths on their last parts. I'll do that here. So this one won't, I don't think I have any corner bends coming together or anything like that. So I don't think this is going to really affect me, but I like to keep this maybe what I did on my other ones. And then the corner, I think we just set this to tear here and get rid of this. And in the event that I do have a corner come together, maybe I need to evaluate this later and decide if that's going to work or if I need to allow some type of trim. But that's all I set here. I think if I select here, this will be the selected one in my menu. When I leave this, I'll say save and close. And then that is the one that I've loaded is my quarter-inch stainless steel plate. So that's all done. And then I'm going to derive in the original solid. Of course, mine is solid 2 is what I've called it because I did make some modifications. So just bring in the solid that's really underneath those other part assemblies. So I'm going to say derive in that my solid, which is in my parts folder. I haven't moved, eventually I'm going to move my solid 1 into my obsolete folder as well. So I have some cleanup still here to do, but this is the one that I've used underlying my other parts. So I'll just make sure I'm using the same solid that I'm using under the other parts. That's another reason why I'd like to purge that other solid so I don't accidentally derive it in. And then I have this weird relationship where I have a different base component under, I'm thinking I'm using the same one. So you got to be careful that way. I'm trying to build this thing systematically. It should be the base solid under all of them the same. So I wouldn't like to mix and match, at least as far as them making these kind of parts. I can make a new solid for other applications, and then I would have multiple solids in here for different, like the even flow hopper might have one, but yeah, I'm going to derive in my solid that I've been using. I'm going to use it as surfaces. Well, I'm going to do one more thing here because I don't think we've toggled through these very much, but I did tell you have access to everything that you've created that solid with. And one thing that I'm going to need, because what this part is going to make are the end plates here. And we design the end plates in the solid to be ready to have some flanges put on them. It's why they're kind of built the way they are. I'm ready to use the flange function. But once I bend this flange, this is going to kind of tie in these loose ends. This is a three-sided flange. when I bend the flange on the end plate, I'm actually going to put the hole pattern in that'll kind of complete this square flange. So that's why that's three-sided. My end plate is going to be the fourth side. And we have the sketch for that. When we created this three-sided flange, there's a sketch with where the hole pattern is in it. And so if I go down through my sketches here, not everything is selectable because I don't have these to work with, but these are expandable. I can get to my sketches. And so you can toggle through here. These are just sketches that are on the base solid on this. How far on these on this one here?
So, like,
Well, I can probably see my sketch here, right? They're 625, 0.625. Yeah. So they're not centered. They're definitely towards the outside a little bit. Yeah. And that's continuous all the way around it. 5/8 all the way around. I don't think that was specifically given. I think that's me. I know. I think it was. That was actually something from the manual, and we I made some adjustments to it, but I kept some of the SEMA manual had that whole pattern listed. It was a little bit overly complicated, and I made mine more symmetrical as far as the whole spacings. Theirs was kind of a bunch of different dimensions, and I didn't want to mix, so I decided I used their 5/8 dimension. I know that's where I got that, and then the spacings I developed referencing their dimensions. Yeah. You put 875. Yeah. That might be the center. I don't know what the center actually is, but yeah. Yeah, like flanges and holes, a lot of times they are centered. Sometimes they are not, and because when I put the hardware in, it's easier if they're a little bit further away from the object. That's one thing. The other thing is it allows me, this is part of the assembly process. It would allow me to like run, you think of like a gasket going in here, like a lot of flanged a lot of flange connections may have a gasket in them. And this would leave place for a gasket to not interfere with the hole necessarily. Some gaskets, they cut the hole pattern in them as well. Some of them, they just cut to the inside of the hole pattern. And sometimes we'll just, in a food processing world, gaskets are great, but they do create more surfaces that can collect bacteria. And so, really, if you think about this, if I have two flanges bolting together and a gasket in between them, I technically have like four surfaces to collect bacteria. So they will sometimes eliminate gaskets and just put a bead of silicone down here, just like your normal like caulk gun silicone around the inside of the bolt pattern, and then squish these together. Then you have a gob of silicone in there. Yes, hopefully that's edible, but they do use. I don't know if they make an edible silicone. I hope not, but they do use food grade grease for oiling or for greasing bearings and stuff like that. They will use a food grade grease, which means if you get a drip or two of that in there, just eat it. Gross, huh? Food grade grease. Yeah, food grade fruit. Yeah, exactly. Gross things, but yeah. And we wonder why we have cancer. Okay. I pretty much can probably blame it on food processing, but
food grade grease.
no comment. But yes, probably. I've never worked there to know, but as long as they're changing that, I don't know. Yeah, grease frying is gross at all. Yeah. I like frying like the next person. I like a fry bread taco. Oh man, I love it. But I always fry my bread outside. So in a Dutch oven outside on a cash cooker is how I do my fry because it is gross. It is messy. Anyway, I can't remember what I was talking about, but bead of silicone in here works great. The whole pattern pushed to the outer is a good thing actually. So I liked that. But what I want to do is include the sketch because I'm going to bend this on. Um, and then I'm gonna need to put a hole pattern in. I have that sketch right here. And so all I do is just turn that sketch on and it will come in as my surfaces come in, here will come in my sketch. I need the same thing over here because I've kind of done the exact same scenario on this end plate where it's going to be my fourth side to that flange. And so I'm just going to scroll through here. This is that sketch for me. And see, we already drew the whole pattern in, so it's just nice to use it. So I turn those two on. Yes, and then I'm just going to say okay, and this will come in with the solids. I'm sorry, with surfaces and with my sketches. Of course, you can always get back and edit that derived part. So that's what's cool about that. If you didn't see that you needed this coming in, you can always get back into it. Oh yeah, uh-huh. Uh-huh. Oh yeah, my S2 is because my original Yeah, I mean, my S2 is because my original solid didn't have like a separate faces here was my main reason for making, and I could have just adapted my S1. So I think some people did that. You could have modified. Yeah, you could have.
Yes, I don't have it for you, but they, that one part. Like the
Mm,
puppets and three parts currently for the bends.
right
That was,
here, this flange here.
no,
Oh, the discharge chute. You do not have this though.
Oh, we used it to, that,
Yeah, this I handled all that back on a different assembly, not this one, but or sorry, a different part. Yeah, this is a whole new part. Like this is not this is quarter inch part. Yeah, so it's not related. That's why I said if you don't have it, it doesn't really matter because I'm not. Oh yeah, yeah, yeah. As long as you made like if you made the corrections to S, the first solid like that I made in my second solid, then then you wouldn't have had to do what I did, which was yeah, I have two solids and I replaced the base component. I kind of did that because it was a good exercise and you can replace a base component. And that was captured in a video. We've only done that once, but these solids can be swapped out. If the event that I have a failed solid or something, I could make a copy of it and bring it in and swap out the base component. So I kind of went through that for that reason more than and then yeah. Yeah. I probably in the real world, I probably wouldn't have made another base solid. I probably would have just continued to modify my solid and keep it. But I thought it was a good time to say, oh yeah, in the event that you ever do this, you can swap out a base solid as a base component. So yeah, good question. I mean, I can do it right here. You can do it on these parts, but let's see. So that's it. I got my sketches, got my surfaces. Let's make a quarter inch part. So I'm just going to do the end plates. I'm just going to do a sketch here and project everything about this end plate over there. Yeah.
same thing with that sketch on it though.
Yeah, I'm keeping this sketch. Yeah, I'm just keeping this sketch. It'll kind of act like a sketch does in a part, and when I use it for something, I think it will turn itself off, like sketches do that once they've been kind of consumed or used for a feature. I think it does that here too, is if yeah. So these were not new sketches. They came in with the yep. And then all I've got to do is trace this thing, get all the clearance holes for the bolts. We made this part one other time, and so you guys probably some of you had this in your 12 gauge part model, and then and I did too at one time. I ended up deleting it out of there, and I decided, yeah, we'll just do each of our sheet metal parts as their own part assemblies with their thicknesses established. One thing that I did learn, when I did make that, it's already in my memory that I didn't want the hole pattern here. I just wanted the center hole for to use the hole tool. So I'm going to shift select all these. Oh yeah, and turn them to yeah, if you select all these or shift select, I'm going to turn them to construction because I only want the center mark to use the whole command. The rest I do want to just have them. They are clearance holes in our solid, so that is the correct hole I want there. It's a fastener that goes through here. This is a threaded hole that I'm going to create, so I'm going to use the hole command tool rather than project that solid hole. That's my technique there. And that is all trace. So I finished that. And then I'm going to face this because we've set our sheet metal rule. So this will face is like extrude. You could also use extrude, but I'm going to use face. Face just needs a sketch, but it does what extrude does, only to the thickness that we've set. So that's that. But I want it to go this direction and lie right in where the surface shows it should lie, like that. That's a new solid. Yes. Okay. It shows up. That's my first solid in my assembly. Um, so I've got these holes that I need to add. I'll have to turn on my sketch to get to them again. But I'm gonna bend flanges on here. So yeah, I'll bend my flanges. What I need to know is how far that flange is, and really, I kind of have I can just measure it here, but I'm anticipating my flange bending from here and over to here. So I'm just gonna do a quick measurement. I don't know what that is off the top of my head, but it's gonna be from here where these line up. These are all on the same plane to here. Yeah, it's 6 and 5/8 or 6 point, or sorry, 1 and 5/8, 1.625. I'll just copy that real quick. Control copy. Because I'm going to take it into my flange tool, flange those things. There's that nasty flange tool. It's pretty complicated, but that is where I want to bend. This is where my dimension's going to go. So I'm just going to copy paste it there. 6.2. I like the look of that, other than this should, because it is acting as the fourth side to this flange. I got to push this bend the other way, not other direction, but I've got to make it so it comes down to this and meets this surface here. So I feel like the one that does that is the position here. I'm not changing anything as I move down through here, just where the measurements or the placement. I'm just going to change bend position here like this and push it down. Now I can see that I'll be on my three-sided part. This will be the fourth side, and they will lie on the same plane or surface so that I can bolt up a mating flange to it to bolt on the discharge chute, which is really a squared around. Well, this is the discharge chute. Now I consider like a squared around below it, or I call it a funnel, but so this to me looks like a good flange bend here. Just adding that. I mean, I'd have to adjust this dimension if I was taking the dimension from a different spot here and I wasn't seeing. It looks like it's going to lie right on my where I'm anticipating from my sketch where it will live. And then I just need an upper one that should be the same. So I should be able to select that edge up here too and apply the same bend to it. And it needs to do the same thing. It needs to lie on the top surface. We don't need holes here though. We don't have the same thing going on. We're not bolting on anything here, other than there are some uh there is a lid that we will build to go over this. We haven't even really discussed that too much. So, but I don't think I'm going to use any hole patterns in that for the lid. And so that this should be good. So I'm just going to say okay, keeping my sheet metal defaults on here and say okay. Okay, now I just need those holes. So I'm gonna use the hole command in the sheet metal tab here, hole command. I could do a new sketch and project it. Well, I'm on that surface, so technically I don't really, I mean, this is where I don't really need to do a new sketch. I've already got a sketch. And so I can just say hole, and let's make these the holes that I want to create. I'll just go back to no selections, but those four places, I want to have that clearance hole. And if you have to go down through here, maybe again, I don't have any seat on it, and I'll be the ANSI screw threads. It's going to be a hex head bolt here, just a standard bolt. And it's going to be the 3/8 size. That's the size that the rest of the flange is using. I would never want to mix and match sizes on a bolting connection like this. I would want to keep these the same fasteners. And then if I go through all, it'll definitely shoot through my top flange. I don't want that in this case. So I'm going to say definitely use my surface feature to next or whatever. And this is the only surface I want to have holes up from my sketch up to that surface. So that's a use of that command. And then I'm just going to say okay. And I've got a completed hole pattern flange there now. That's kind of unusual, but I mean, that's not totally unusual, but this is kind of a unique situation where I use two parts to make the flange. Oh, like I don't, let me see I'll edit my features here. Yeah, mine's a drill point. Technically, you could just do flat because it is just through. So yeah, that's a good point. It doesn't really affect this. This is a through hole. So yeah, that's good. Yeah, this definitely comes into play. Like think of that when you have what we call as a blind hole, and that means my hole doesn't go all the way through, and I need to kind of consider how the end termination is in a blind hole. That's a really common type of hole in the mechanical world is a blind hole that I have to worry about how it ends and how far I can thread it to get, those are really critical because what you're doing is you're putting generally they're threaded holes when you're doing that. And then so we're threading in a fastener, and fasteners have to be threaded in the correct amount to carry the load, right? You have to use the right size fastener and have enough threads to catch all the threads that are required to carry that load. And so those blind holes are really critical.
What are the those credit, whatever.
These ones here. Oh, right here. Oh yeah, I can't remember. I'm gonna have to look this up. I think I'm gonna go to the bearing. Yeah, we did do it on the, I haven't done it yet, but yes, that's good. That's my next thing is I got to make these holes. I got to turn back on um the sketch that I made for the face because I'm going to turn this back on. And then I got to put holes in here. I can't remember. Yeah, so what I'm going to do is for me, I'm going to go to my yeah, I'm going to go to my resources because I've saved resources for my two bearings here. These are just the PDF sheets that I pulled from McMaster Carr, right? And I have one that is the drive bearing, which is the end I'm working on right now, is the drive bearing. And so it looks like this. It's a big kind of thrust load bearing. The other one I have is this one here, right? And I'll need both of these essentially. That's the driven bearing on the inlet side. So I think what I determined is we've made ours match this. Um, 687. Well, and I could check my solid. I think we actually spent the work on the solid, actually, figuring out what we were threading at. I think I did 5/8 here. Is that what I did? Or did I do half inch maybe and then I'd have a pretty sloppy fit, but um here I know they're half-inch holes, and so I use 7/16. I remember that for sure. It's a little bit of an oddball size, but not. It's readily available usually on shelves. 3/8, 7/16, half inch, pretty common size. So I know I think I use 7/16 threads for this one. We just need something that will clear through here. This is their the fastener that I'm going to thread in my end plate is going to just pass through here. It's not going to thread into these are a through hole on these. They just slip over a bolted connect or a bolt or some kind of fastener. So I just need to have a fastener that's undersized half inch and is still readily available. 7/16 made the most sense to me. Um, so what I'm going to do is that last hole for the driven end here or the drive end. And I want these to be my next hole pattern here, 4 positions. And they are a threaded tapped hole. I don't have any seat on them. I just need them to pass through square. It picked that for me, or at least maybe it was my last time. I don't know why that is, but that's what I want is an ANSI 7/16, 4375. 7/16, 14 is a course, 2B is the class, right hand threads, yes. Through all, I think will work great here. That's just one solid without any complicated features necessarily to worry about. And that's it for me. I think that's what we used. Hold on, don't go so fast. Yeah, I'll bring it back up. Yeah, yeah, yeah. Let me see here. I'll say okay on this one. So this hole, this one that I did here. Yeah, I have this. Yeah, I have this sketch that's now been consumed, but I brought this in with the solid, and so I didn't re-sketch all this. And if you didn't bring it in, that's okay, because you can get back into your derived part right here that lives right below your origin. This is your derived part, and so if you need to edit that derived part, you just go to edit, and it brings up that first menu that we brought in. I had just toggled on these two sketches to bring in with it. And so instead of being grade and minus, that's funny. It looks like a little fastener head. I kind of dig it, but um, you just click through here and you can add those in if they have this little plus sign. I've activated those. That's how you can activate them. Just click on that. That's off. That's on. So that's the first time using that, but you can use that on other features too that are associated with the solid. And so I brought in both of those, that one and the other one is this one here on the inlet end. And I'm gonna have to do the same thing and use it. So when I brought those in, I had them like that. And then when I did my flange bend first, this is an order of operations things, right? I've got to have that flange bent on there, and then I cut the hole through the flange. And so this wasn't turned off until I used it, but it was turned on like this after I'd done all my flange bends, and then I just did a whole command. where I didn't even have to do a new sketch. I was just able to select those from the, yep. And they are just through holes for a 3/8. These are clearance holes. This is what we did a lot on our solid. I mean, you may not remember, but that's what we were doing for a 3/8 clearance hole. And then I terminated it right here though, surface termination, because I don't want it to shoot through. If I select through all here, it'll put a hole through my top. I don't want the holes up there. I just want them right here. That's it. This end plate is done. It's got threads on it. Yep.
Was it, construction?
Yeah, when I projected them, I changed them to construction because I didn't want to have to it wouldn't be the end of the world if you did. You would just have to go through and select those profiles to make solid with the original face solid. Because I don't want them to just be through, I don't want them to be just like I need them to have threads in them. And yeah, yeah. Technically by making them construction, they didn't even select for me. Yeah. So
I definitely totally did not have to completely go back through several parts and assemblies to fix one tiny mistake and got lost past the flanges.
well, hey, I'm going to do it on the other end, so it's going to be the same steps over here. It's a little different shape. One thing I'm going to go check is what I did in my, I'm going to check what I did in my solid for the, because I think I added the threaded features to my solid, didn't I? Yeah, yeah, I can tell there's a shadow of a thread here. Um, so I'm just going to check that really quick, which I'm just going to open that solid and see. I think I would have, I don't know if I used 1/2 inch. It's quite undersized for the bearing necessarily, but so I'm just going to my part real quick. That is my solid, or this one here. I don't have it open yet, so I'm just going to open it. I can just leave it open over here. I'm just going to go check this hole and see what I used here. It's one of these. That's the hole it is. So I'm just going to take a quick check here. I did use 1/2 inch. So what I'm kind of tripping out on a little bit and thinking about is that I think that's going to be fine. Of course, I could always go back and change it later anyway. But I'm looking at my data here again. You know, this is with a new set of eyes. I haven't looked at this for a week or so, but I'm like, I like my 7/16 to hold up this one. I'm undersized of this, but I'm not hugely undersized. 3/8 would be pretty sloppy. It's a 16th undersized, so it would have like a 32nd all the way around. It's almost 30 thousandths clearance. On this other one, though, just by the nature of it, for whatever reason, the way it's built, they put a 0.687. That's almost 11/16. 6.875 would be 11/16. It's a fairly large hole. So I could put a 5/8 fastener on there. That's 0.625, and that's a common fastener. Looks like I chose 1/2 inch. I'm not sure what I was thinking, other than
Good job.
yeah, like because what I'm tripping out on you guys is just that if I bring up my calculator, this is 0.687. If I put a 1/2 inch major diameter screw thread through here, it's that big. It's almost 3/16. I'm gonna just divide this by 2 because that's what you'll see all the way around it. I think of it, it would have like 90 thousandths, 93 thousandths clearance all the way around a 1/2 inch bolt through a 0.6875 hole. That's what I would call a sloppy fit. So maybe I might rethink this and say, I think a 5/8 fastener might be better. That's pretty big. The other thing I kind of like about having that drastic step between the two is that a 7/16 and a 1/2 inch are quite close in I mean they're really close. That like just looking at them at a table with a bunch of fasteners, it would be harder to pick the difference between a 7/16 and a 1/2 inch fastener. It would be hard to make a mistake in somebody assembling this if one side has 5/8, the other side has 7/16. You can't even mix those two up. They're drastically different from each other. So that's kind of nice in some ways, and slightly weird. I'm surprised. What I'm kind of weirded out on is why does this bearing have such huge holes in it? I don't know. It's just how it's manufactured. So I could think back and say, well, maybe I want a 5/8 there. Um, but these can be changed pretty easy. If I feel like if I'm going to make that change, I probably should do my due diligence and make that change here on the solid, so I'm not reflecting something different. And so So I might just take a look at that here. So I'm on my solid. I'm gonna do an edit feature on this. And I'm just going to change this to say, well, actually, maybe it's going to be 5/8. That's 0.625, a 5/8 11 UNC, right hand thread. This is changing the solid. I'm going to say, okay. It's a pretty big bolt. Yeah, I think I'll put that in. It was my hole on my solid. It's on my inlet end, is what I say. It's on the inlet end of this screw conveyor. Yeah. Yeah, and it's just because I'm looking at the resource material for the bearing. I'm just kind of analyzing that, saying, man, if I put a 1/2 inch bolt in there, I could put in. I made it 5/8. So I actually changed this instead of I had a 1/2 inch originally, and all I did was change it to 0.625, and that created a 5/8 11 thread in there. This kind of stuff happens. I mean, you put a new day, a new set of eyes. Um,
Yeah, almost that.
Yeah, my go-to gut would be like I wish my bearing had both the same studs in the ends to support both bearings with the same fastener. Unfortunately, just by the nature of the bearings I'm purchasing, I definitely anyway, I can't get away with that. I don't feel like one is going to be really sloppy fit, and the other one has to be a 7/16 because I can't use a 1/2 inch bolt over there. I'd have a size on size issue, and it'd be hard to slip over the bearing onto the studs. And you'll see what I mean when we make the studs. I know that's a little vague, but I'm going to make a part that holds up that bearing. I mean, I could use a bolt, but I'm not going to use a bolt. I'm going to use a headless bolt, which you can buy those actually. You just buy a stud. You can also just make them easy too. I mean, yeah, stud welder will actually take. They're kind of special studs that are, yeah, that sometimes I have little flux, like you can buy these. Yeah, that's a welded stud sometimes is spot welded on, and they sometimes come with a little like a ceramic little ring around the end where the welding happens, almost like a little it's just a little flux ceramic that allows it to actually make a good fusion. Because even a spot welder can be prone to contamination in the weld zone because it is liquefying. But yeah, anyway, good. Uh, so that's all the change I've made here. This should update this. Well, yeah, that's going to want an update. That's on my drawing. I didn't mean to go to there. I meant to go back to my part. It needs an update because it has that underlying base solid. So I'm just going to hit update. It you can see that it updated on my in my derived part here. I can see that changed. I haven't even saved this yet, so I think I will go ahead and save this at this point. I'm going to save it in my parts folder. So I'll just say save in my parts folder. 012 is my last one. Whatever number you're on next, that's fine. You just use it. Yeah, and it doesn't have to match. Like I would just go with whatever numbering sequence you're at. I know some people maybe have already made a 13 part or whatever. That's fine. Just I would pick the next one in the sequence. Doesn't even matter to me if your numbers match mine. So, but I'm going to name mine 13 just because that's the next one in my sequence. If you've had failed parts and all that jazz, then you'd have a different numbering sequence. Doesn't matter. So say save. Yep, save. I just did that because I've done some work. I don't want to lose it if it crash here. Let's do this. So this sketch is consumed, and this sketch I don't need anymore either. And I'm upside down and backwards. Here we go. So now I'm going to do another sketch over here and just face this. So can I don't think I can just face this. Yeah, you can't face without a sketch, I don't think, but you can thicken and you could thicken this and do that. I mean, the reason why I'm doing face sketch, I don't know. It's just what I jumped into today. But you could totally use the thicken command and thicken this as well. I think you would get these holes in here that I have to fill or something. So that's one disadvantage of the thicken command here. So I'm going to stick with the sketch and just do the projection sketch from that. And that might be the reason why I did that. I really didn't think about it too carefully here, but project my geometry. Let's see. In the event that thicken fails me, my next thing is always I go to like this method of like a sketch and a face. Um, and I think you'll experience that if you ever get into this kind of work that sometimes thicken just fails and there's really no good reason for it. Maybe they've made it better over the years, but it used to be a little bit more notorious. It's it's probably an operator error for some reason, but I felt like I've had issues with thicken. And sometimes it crashes, but yeah, exactly. And I'm going to do the same thing here where hey, one thing I'm kind of noticing, if I hold down shift and select, oh, no, man. Somehow I'm getting to a quick access of like adding construction lines. I don't know what I'm doing, but I kind of like it. I'll have to figure it out. This is what construction.
When you're holding down shift and you click on that thing.
It does make him construction. Is that what it is? Yeah. So I think I was just holding down shift and selecting. Well, is that right? Something.
Well, but when you go to project geometry, if you're holding down shift over.
Oh yeah, cool. If you're holding down shift when you project, that's what I've done a few times and been like, hey, I like that. That's a feature I haven't noticed before, but I like it. Hold down shift and select, and it's yeah, that is handy. That would be a button I'd put on my 3D mouse to hold the button down and then select. That'd be perfect. Because yeah, that is kind of painful to always have to toggle it on here. So yeah, all these little secrets. This is done. This sketch is done for me. I just need to face it. That sketch. I need to be a new solid here, like we've done this. And make sure it fits in the plane where I'm expecting it to fit. That looks correct. Yeah, new solid. Make sure it's going the right way. There's my new solid. I should really have the same flange over here. I think it's probably going to be the same parameters. I'm just going to do a quick little double check here that this dimension, I think, should be 1 5/8 like it was the other. Yeah, 1 5/8. That's good. That's some symmetry that I'm kind of looking for. Technically, I think the same flange, well, the mating flange to this end will be the same as this. So it's like I only have to make, and what I mean is the mating flange is the one that's going to bolt up to these. They're actually the same. So I'll only have to make one part. I can cut out a couple of them and use them there because one will hold up an even flow bin, one will hold up the discharge squared around. So yeah. So I'm going to flange that. Yeah, flange it. And it needs to be 0.625, which is good. Looks like it's matching my sketch. It's going to go to, oh yeah, just, oh, it is. Yeah, yeah, yeah. I am kind of careful when I do that, but it really, yeah, if you pick that one and to go that way, and then you just have to pick edge set again. I think you can hold down shift to unselect one and then select it again. And I tend to do that more than I would like, well, I'll just switch the direction this way. I mean, you can always correct it there. I tend to try to bend it from the edge that I'm anticipating it to be bent from. But yeah, some people might just toggle the other direction, but that's it. I'm going to say okay on that. No other changes for me. Really, it's the exact same format as the last bend. And then we just need to put our holes in here. So I still need this sketch on. And I still have this sketch on, but I'm going to consume it now. This one up here will be the clearance holes like this are for a 3/8 fastener. So I'll do the same clearance hole. It's all set up for 3/8 fastener on mine. I'm going to have to select the surface maybe, or through all here would work, but I think I probably will just select the surface for these 4 positions and say that I just want them to go through this surface. Oh, I haven't selected my solid yet. Let me select my solid. There it is. Yep, that's right. Okay. Yeah. There it is. All of its beauty. I'm going to do these holes as 5/8, these next 4, and the whole thing. It's just, oh, that surface is on maybe a little bit. So was that for the hole here?
Yeah.
Oh, sorry, I went to the sketch. Finish that real quick. Hole these holes here. Yeah, so edit the feature. Yeah, if I X'd out my solid, the reason is because you're overlapping on a surface, I think. Like maybe just try to reselect, or is it not even able? Yeah, you could turn your surfaces off because or just turn the visibility off because you already have the solid there. Mine is able to select it pretty easily, actually, but it's, yeah, yeah. You want it to be hooked to that solid for sure. So, or just in that solid. So what I would do is if I'm having issues, I just come up here to the surface bodies that are underneath my solid bodies, and I shift select all those, and then you can hide their visibility. Bam. And then it will be easy to select that solid. So pretty common. You have to turn off those surfaces. They are annoying at times. Yeah.
Kind of far away.
This here. Okay, so with the hole here. What? Okay, so we're having troubles on this.
Did you do the flange and then?
And then it won't let us select the auto.
Okay. I don't know. Let me see what. Oh yeah, maybe like. Let's see here. Let me just analyze mine a little bit. So I'll just bring mine up. But I don't have those holes in. So you were able to get the face solid done, right? You got your face. And then when it faced, it turned off this sketch like that. And then on your flange, if I go to edit its feature, I don't even know if it'll let you make a new solid there, but I wonder, your flange bent just fine though. Okay. I'll come look because I don't know. Yeah. I'll take a look and see what I can see. Because then I went to my whole pattern and I had that sketch on. Yeah. So let me see. I'm not sure.
Bring up what your settings were for the holes to find where it's automatic.
Yeah. You see here. I haven't totally studied. Did it actually work? Is it the direction of the hole maybe or the Oh yeah. Well, one thing I would check here real quick is as I'll go back into this whole pattern. Um, I think if you were going the wrong direction, I don't really know if it'll let you though, by the way I'm doing it. Yeah. Was this one that you needed, Sky? Was this?
Yeah.
S- Yeah, clearance and for 3/8. Yeah. And then I've gone to this surface right there. Okay, I'm coming. Let's see what it is. This is a good place to pause anyway and take a break. So that's perfect. I think we can stop right here and I'll